Hi, and welcome to Module 10. In this module, we'll explore the life of stars from birth to old age. Gas and dust exist in the space between stars.
These are called protostars and pre-main sequence stars. And they are formed in nebula regions, the big clouds of gas and dust, which as the gas and dust collides forms the stars and planets in space.
This is not just a plate of burned chicken. The charred layer created by overcooking chicken, like exposure to intense electromagnetic radiation, contains just carbon and hydrogen. These carbon and hydrogen compounds are components of the interstellar nebula clouds. Technically, this compound is called a polycyclic aromatic hydrocarbon. The dust and star-forming region of Cygnus DR21 is a strong radio and infrared emitter. Green denotes areas of carbon monoxide and molecular hydrogen. The red filaments are polycyclic aromatic hydrocarbons. These young stars in the constellation of Orion are still surrounded by much of the gas and dust from which they were formed. Let us peek into the region of the constellation of Orion for some spectacular examples of nebulae. Remember that historically, constellations were imaginary configurations of stars after a person, object, or animal. Today, constellations are defined into 88 contiguous regions that cover the entire celestial sphere and all the objects in that region. Now, let's look at what is affectionately known as the Great Nebula of Orion, found in the Sword Sheath. The middle star of the three that make up Orion's sword case is actually an interstellar gas cloud called the Orion Nebula. Within the area shown are four hot massive stars called the trapezium. They produce the ultraviolet light that makes the nebula glow. This nebula of gas and dust is 1,600 light-years from Earth, has a diameter of 16 light-years, and a mass of about 300 solar masses.
So this ball of gas that is right here in the sword belt is not a star, it's a ball of gas, a nebula region of free gas in space that has the mass of over 300 suns, meaning that there is enough free gas in this region of space to form 300 stars the size of our sun.
The Horsehead Nebula is one of the sky's most famous treasures.
So what we see here is a bright and dark nebula region in space. The horsey region in front is a dark nebula cloud in front of a bright nebula cloud.
A Bok globule is a small dark cloud only about 1 light-year in diameter that contains 10 to 1,000 solar masses of gas and dust. They are believed to be related to star formation. This image shows dark Bok globules in IC 2944. These dark spots in the above picture are not photographic defects, but an unusual type of interstellar cloud known as a Bok globule. Bok globules, named after astronomer Bart Bok, who studied them extensively, are small dark clouds made of gas and dust that are typically condensing to form a star or stars. These Bok globules are found in front of a glowing H2 region known as IC 2944. These opaque clouds of interstellar gas and dust are so large they might be able to form stars. Situated in rich star fields and glowing hydrogen gas, these opaque clouds of interstellar dust and gas are at home in the nebula known as IC 2944, a bright stellar nursery located about 5,900 light-years away toward the constellation of Centaurus. EGGs are the evaporating gaseous globules.
We see with the arrows, what's happening is as the gas condenses into gas balls, stars start to emerge from the nebula regions.
Protostar is the earliest stage of a star's life before fusion begins and when gas is rapidly falling into it.
The life cycle of all stars depends on their mass.
Clusters of protostars are indicated by yellow circles. This nebula, 13,700 light-years away, is converting some of its gas into stars. This infrared image reveals over 300 protostars. Some 3 million light-years away, in nearby spiral galaxy M33, giant stellar nursery NGC 604 is about 1,300 light-years across, or nearly 100 times the size of the Orion Nebula. In fact, among the star-forming regions within the local group of galaxies, NGC 604 is second in size only to 30 Doradus, also known as the Tarantula Nebula, in the Large Magellanic Cloud. The space-age color composite of X-ray data from the Chandra Observatory and Hubble optical data shows that NGC 604's cavernous bubbles and cavities are filled with a hot, tenuous X-ray emitting gas. Intriguingly, NGC 604 itself is divided by a wall of relatively cool gas. On the western, right side of the nebula, measurements indicate that material is likely heated to X-ray temperatures by the energetic winds from the cluster of about 200 young, massive stars. On the eastern side, the X-ray-filled cavities seem to be older, suggesting supernova explosions from the end of massive star evolution and contribute to their formation. Emission nebulae harbor young star clusters. This emission nebula, M16, is an H2 region in space.
H2 is just an astronomer's way of talking about a fancy region of hot hydrogen.
This is an image of the vicinity of the Cone Nebula. Strange shapes and textures can be found in the neighborhood of the Cone Nebula. The unusual shapes originate from fine interstellar dust reacting in complex ways with the energetic light and hot gas being expelled by the young stars. The brightest star on the right of the above picture is S Mon, while the region just below it has been nicknamed the Fox Fur Nebula for its color and structure. The blue glow directly surrounding S Mon results from reflection, where neighboring dust reflects light from the bright star. The red glow that encompasses the whole region results not only from dust reflection, but also emission from hydrogen gas ionized by starlight. Now read about the Cone Nebula and click on any of the green links for more information.
Unfortunately, viewing the video, you cannot click on the links. However, just read the screen. Okay.
Now read about the Emission Nebula and click on any of the green links for more information.
Same situation. You can't click on the green links, but please push pause and take a look at the meaning of Emission Nebula.
Review the following information about the main sequence and giant stars.
Remember, stars are grouped into main sequence, giants, and dwarfs, and they all have characteristics. Most stars in the universe are main sequence stars, performing hydrogen-helium fusion in their cores, such as our Sun, and this gives you some details of main sequence.
When the Sun is a giant, it will draw its energy from a hydrogen-fusing shell surrounding a compact helium-rich core.
What we see here on the left is the current size of the Sun. When it runs out of hydrogen in 5 billion years, it will burn helium and expand to a red giant size, so large that it will engulf the inner solar system.
So what is the fate of our Sun and the end of Earth? Well, our Sun will expand to a red giant in approximately 5 billion years. It will expand into the Earth's radius, causing the Earth to be incinerated. Our Sun may also form a planetary nebula, and our Sun's core will become a white dwarf.
There is another theory that says instead of collapsing to a white dwarf, the possibility is our Sun could collapse to what's called just a planetary nebula, which is just, again, a big bunch of free gas in space after the star has collapsed.
Stars on the main sequence, with masses between 8/100ths and 4/10ths of the solar mass, have a completely different life. As stars pass through their life cycles, their positions on the HR diagram shift.
This is a computer representation of the life track cycles for 5 different stars as they move throughout their life phases.
Globular clusters are bound groups of old stars.
Again, we know this from our Hertzsprung-Russell diagrams. We can measure the ages of stars relatively. So in this module, we've learned about protostars, main sequence stars, nebula regions of gas and dust where stars are born, some of the properties of stars, and the interesting dark clouds called Bok globules.